Good afternoon, everyone, and welcome to today's Kent Seminar Lecture. Today, we are very happy to have Major Franck Nago as our speaker. Major Nago serves as a Senior Research and Development Acquisition Advisor at the U.S. Army Corps of Engineers. His research focuses on advancements in technology related to force protection, maneuver, and infrastructure. Major Nago holds a doctorate in business administration from North Central University and 2 master's degrees from DeVry University. He is currently pursuing a doctorate in cybersecurity. Everyone, please join me in welcoming Major Nago to the seminar.
All right, good afternoon. Could you guys hear me? Yes, so first of all, I want to say thank you, Lada, for this fantastic introduction. Yes, I am Major Franck Nago. I have a PhD in business administration, and I'm currently working on my second PhD in cybersecurity. I am with USACE, the Army Corps of an Engineer. Before I joined USACE, I was with PEO at AWS. So PEO is the Program Executive Office for Intelligence, Electronic Warfare, and Sensor, where I led several Army programs. And then from there, I was the LNO with PEO at AWS with CENTCOM AO. CENTCOM here, that's the Central Command. Basically, it's what we call the Middle East today, where I oversee the whole program. I also oversee the North portion of Africa and also the East portion of Africa. So I joined USACE roughly 1 year ago, where I work for 2 technical directors. The first one is Mr. Jim Allen, the technical director for operational science and engineering. And the second one is Dr. Justin Berman, who is the technical director for infrastructure science and engineering. For Mr. Jim Allen, my job is to look at across the lab portfolio and identify some specific technologies and build a glide path to transition those technology to the military. For Mr. Justin Berman, for Dr. Berman, my job is to work on something called VTime. VTime stands for the Virtual Toolbox for Installation Management Effectiveness. It's a software-intensive program which has a goal to build what we call the installation of the future. So that's really what I do. So with that said, I want to say thank you for the opportunity to join your forum and to talk today about the U.S. Army perspective on electrifying transportation. 2 things that I want to highlight before I start the brief. This is the unclassified brief, so which means that I won't talk too much about some technical specific things, right? So if there is any technical aspect that you want to know, feel free to send me an email, and assuming that you have the right credential, we will refer you to the right office. All right, so this is the agenda. We're going to start our dialogue first with a background, and then from there kind of transition slowly on the benefit of electrifying transportation. I'm going to kind of talk a little bit about where we stand when it comes to the state of Army transportation. I'm going to highlight the different type of electric vehicle from our standpoint of view, what we're tracking. One thing that's very important, talk about the technological challenges. 2 key slides is the pathway to vehicle hybridization. This is a very important slide. And this following slide, which is the strategic glide path to all electric. If you're not getting anything from this brief, at least remember those 2 slides. One thing I want to highlight for the pathway to vehicle hybridization and the strategic glide path to all electric, both slides belong to DevCom. DevCom stands for what we call the development command, right? And then at the end, I'm going to talk about ERDC, which is really the organization that I belong. We have a couple of initiatives when it comes to electrifying transportation for the Army. With that said, I'm going to move to next slide. So, right, so the background. So that's really very simple, right? So the background when we talk about the Army electrifying transportation is really driven by the 2022 Army climate strategy. And you can see the objective. We have 2 key things that we try to do. First is to field a purpose-built hybrid drive tactical vehicle by 2035. And the second one is to feed the purpose-built also fully electric hybrid vehicle by 2050. And the second one is to reduce the Army greenhouse gas emission by 50% by 2030. At that point, I'm going to move to next slide. So the military has long relied on traditional fossil fuel powered vehicle, which, while effective, come with significant drawbacks, such as high fuel costs, logistical challenges, and environmental impact. So as technology advances, the potential for electric vehicle to revolutionize military transportation become increasingly apparent, right? So why? First, electrifying military transportation is not just a matter of keeping up with technological trend, it is a strategic imperative. Electric vehicle offer operational advantage, including improved torque and low speed performance, which are crucial for off-road and rock terrain operation. Additionally, electric vehicles have lower sonic and thermal signature, making them ideal for stealth mission. That's mean low noise mission. This stealth capability can provide a significant tactical edge in recon and surprise attack. Moreover, the shift to electric vehicle aligns with broader sustainability goal, reducing reliance on fossil fuel, decrease the military carbon footprint, and also enhance energy security by minimizing dependency on volatile fuel supply line. And finally, embracing electrification position the military as the leader in advanced technology, setting up a precedence for innovation and future readiness in an increasingly electrified world. At that time, I'm going to move to the next slide, slide number 5. So this slide describes what we call the concept of army transportation, right? So the military has historically relied on traditional vehicle powered by fossil fuel. So this vehicle include tank, truck, and aircraft have been the backbone of military operation for decades. While they have proven effective in various terrain and conditions, their dependence on fossil fuel presents significant challenges. The logistic of supplying fuel to this vehicle, especially in remote or hostile environment, can be complex and risky. Additionally, the fluctuating cost of fossil fuel can strain military budget and, of course, impact operational readiness. So this leads to several challenges, right? I think high fuel costs, logistical challenges. So the cost of fossil fuel is a major concern for military operation. Fuel prices are subject to market volatility, which can lead to unpredictable and often high expenses. These financial burden can divert resources from other critical areas such as training and equipment maintenance. One of the other challenges that we have to take in consideration is the logistical piece. So ensuring a steady supply of fuel to military vehicles in the field is a logistical challenge. It's almost a nightmare. Fuel convoys are vulnerable to attack, adding a layer of risk to operation. The need to protect this supply line can also divert personnel and resources from primary mission objective. And of course, you have what we call the environmental impact. So the use of fossil fuel contribute to environmental degradation, right? So military operations generate significant greenhouse gas emission, which have long-term impacts on global climate change. Reducing the military carbon footprint is not only a matter of environmental responsibility, but also align with broader national and international sustainability goals. So at the end, by understanding these challenges, we can better appreciate the potential benefit of transitioning to electric vehicle in military operations. So those are the key things that I truly want to highlight with this slide here. So let's talk about the different type of electric vehicle, at least from our ends. So there are 3 types. So I'm sure you guys may be all tracking. The first one's all electric vehicles. So all electric vehicles are powered solely by batteries and produce zero emissions. So this vehicle are equipped with electric motor that provide instant torque, resulting in quick acceleration and improved performance. The absence of an internal combustion engines means that all electric vehicles operate quietly, making them ideal for stealth operation. Additionally, the lack of tailpipe emission significantly reduce the environmental impact, aligning with sustainability. Therefore, and one thing that I want to highlight, at least when it comes to all electric vehicle, is the primary challenge for all electric vehicle is the need for a robust charging infrastructure to ensure that they can be recharged efficiently in the various operation settings. The second one that I want to talk about is the hybrid vehicle. So the hybrid vehicle combines an internal combustion engine with an electric motor, offering, of course, the best of both worlds. So this vehicle can switch between power sources, optimizing fuel efficiency and performance. Hybrid are particularly advantageous in scenario where extending range and flexibility are required. So the internal combustion, for instance, the internal combustion in the case of hybrid vehicle can take over when the battery is depleted, ensure that the vehicle remain operational. So this dual power system reduce fuel consumption and emission compared to traditional vehicle. And of course, the last one is the fuel cell vehicle. So of course, fuel cell vehicle, they are by definition powered by hydrogen and are known for their high energy efficiency. These vehicle generate electricity through a chemical reaction between hydrogen and oxygen, producing only water vapor as a byproduct. Fuel cell vehicle offer a longer range and quicker refueling times compared to battery power electric vehicle, making them suitable for extended mission. So the high energy efficiency and low environmental impact of fuel cell vehicle make them a promising option for the future of military transportation. However, always, the development of hydrogen refueling infrastructure is fundamental to support the widespread adoption of fuel cell vehicles. So by understanding the different type of electric vehicle, we can, as a community, better appreciate the potential application and benefit for military operation. Now, what I want to do, I want to talk about some of those technical challenges. So there are 3 technical challenges that I want to cover. I'm going to start first with the infrastructure. So one of the primary hurdles is the need for a robust infrastructure to support electric vehicle. This include the widespread availability of charging station, especially in remote and combat zone where traditional fuel logistics are already complex. Ensuring a reliable power supply in this area is essential to maintain operational readiness. The second thing that I think is very important to discuss is what we call battery technology. So current battery technology presents another challenge. While advancements are being made, batteries still face limitation in terms of energy density, charging time, and overall durability. So this factor can impact the range and performance of electric military vehicle, making them less reliable in high stake situation. And the last one I want to cover is the cost. So the financial aspect cannot be overlooked. The initial investment required for electrifying the military fleet is substantial. This includes the cost of new vehicle, infrastructure development, and training. Additionally, while electric vehicle may offer long-term saving in fuel and maintenance, the upfront cost can be a significant barrier. So addressing these challenges require a concerted effort in research, development, and strategic planning. And I believe that by overcoming these obstacles, the military can fully leverage the benefit of electrified transportation, enhancing both operational efficiency and tactical superiorities. The next 2 slides are very important, slide 8 and slide 9. Like I said earlier in my introduction, those are DEVCOM of slide. DEVCOM stands for Development Command slide. So before I talk about the slides, what I want to do is a couple of things I want to highlight. First, I want to talk a little bit about what we call the Electric Light Reconnaissance Vehicle, or ELRV. I want to speak a little bit about the hybrid tactical vehicle in the U.S. military and talk a little bit about retail. So the Electric Light Reconnaissance Vehicle, like I say, ELRV. So the U.S. Army is actively pursuing the development of an electric light recon vehicle to enhance the capability of the infantry brigade combat team. When we talk about the brigade combat team, we're talking about roughly around 800 to 1,000 soldiers. So the ELRV, so the electric light recon vehicle, aim to provide enhanced mobility, lethality, protection, and mission load capacity for a 6-soldier scout squad. The electric light recon vehicle program is part of the Army broader strategy to modernize its fleet with hybrid and fully electric vehicle by 2050. The second type of vehicle or program that I want to speak about is the hybrid tactical vehicle in the U.S. military. So the U.S. military has been integrating hybrid technology into tactical vehicle fleet to improve operational capabilities and also to reduce fuel consumption. Notable examples include the hybrid electric Bradley fighting vehicle and the joint light tactical vehicle. These hybrid vehicles offer extending silent watch capabilities, silent mobility, and increase onboard power generation. So the hybrid system also reduces the vehicle heat signature, which is fundamental for military operation and sound, making them less detectable in combat scenario. We have what we call the Rapid Capability and Critical Technology Office, so and that we refer to as RICTEL. So RICTEL has been actively testing this vehicle in real-world military setting to validate the performance and efficiency. So now I'm going to kind of orient you to the slide from upper left to upper right from the vehicle platform. I kind of want to kind of highlight some of those key milestones that I think are very important in our strategy to reach 100% electric vehicle by 2050. So some key milestones that I want to highlight. In 2022 is to have a delivery of two Bradley hybrid electric vehicle prototype. 2023 and 2024, the delivery of one joint light tactical vehicle and two high mobility multi-purpose wheel vehicles, sometimes referred to as Humvee, hybrid electric prototype. 2024 begin the development of hybrid electric high mobility multi-purpose wheel vehicle, like I said, Humvee, and joint light tactical vehicle that we also refer as GLTV. In 2025, what we want to do is we want to begin the production of entire idle transmission integrated generator for the joint light tactical vehicle, but also for the family of medium tactical vehicle referred to as FMTV, and also for the heavy tactical vehicle referred to as HTV. In 2027, this becomes a very important year for the Army. We want to have what we call the operation demonstration of those hybrid electric vehicles. That's where we take them to the field. We demonstrate that in an operation environment to make sure that the vehicle does exactly what we want the vehicle to do. And assuming that we come from those texts with a success, then in 2028 or at the end of 2028, we want to truly start the production of what we call the hybrid electric Humvee and GLTV. So this is a very important slide. I know there are a lot of information over there, but like I said earlier in my introduction, if there's anything that you want to take from that conversation, at least make sure you truly understand that slide. Feel free to reach out to me, right? If you want to know more, again, based on the different credentials that you may have. I'm going to move to the next slide, which is slide number 9. So it's really, how do we get there, right? We say all those things, but how do we get there, right? So the way we're going to get there is the 3 main phases. So phase 1 is near term, phase 2 is midterm, and phase 3 is far term. So in phase 1 near term, 2027, the focus is on a hybrid electric light tactical, okay? In phase 2, midterm 2035, the focus is on electric sustainment solution and early transition to all electric. And phase 3, the focus will be on phase 3, far term 2050, the focus will be on all electric sustainment. So 2 important slides, like I said earlier, slide 8 and slide number 9. What I want to do now is kind of speak about what we as ERDC, part of UCAS, are doing to kind of help the Army and the military to reach that goal. So we have 2 vehicles here that I want to talk about. The first one is called H2 Rescue, and the second one is called All Electric Stag Utility Terrain Vehicle. So I'm going to start with, of course, the first one. So the U.S. Army Engineer Research and Development Center is actively involved in several innovative electric vehicle research and development effort. You have the H2 Rescue, characterized by zero emission, disaster relief type of vehicle. ERDC has collaborated with various government and industry partners to develop the H2 Rescue, a zero emission fuel cell powered emergency disaster response vehicle. This vehicle is designed to provide electric power, heat, water, and essential supplies during natural disaster. It features a high capacity hydrogen tank system that enable the vehicle to complete long distance trips while supporting continuous electrical load for extended period. So the H2 Rescue can also serve as a mobile command center or climate control space during emergencies. The good news is we have that vehicle here in our campus. So if one day the team want to stop by, please let me know, and then we can coordinate and you can see the vehicle from your own eyes. The second piece is what we call the All Electric Stag Utility Terrain Vehicle, the UTV. So this is a partnership, right? So in partnership with Vulcan e-Power Sport, ERDC has received its first all-electric stag utility terrain vehicle. This vehicle is part of a broader effort to electrify the battlefield and support government fleets electrification goal. The stag UTV is being currently tested at ERDC Contingency Basing Integration Training and Evaluation Center, also referred to as CBTEC. And the goal is to evaluate performance and the impact of charging electric vehicle on tactical electrical grid. So this collaboration aims to enhance the capabilities of electric vehicle for both the military, but also for emergency response applications. So this project highlights ERDC, in this case, ERDC and USA's commitment to advancing electric vehicle technology to improve operational efficiency and support disaster relief. So what to take from this dialogue? So what in conclusion? So I think in conclusion, the key thing to remember is that electrified military transportation presents a transformative opportunity for enhancing operational efficiency, first, reducing environmental impact, second, and also aligning with future strategic needs. The transition from traditional fossil fuel powered vehicle to electric alternative offer numerous benefits, including reduced fuel dependency, enhanced stealth capabilities, and improved performance metric. However, like discussed earlier, this transition is not without its own challenges. So addressing the technical and logistical hurdles, such as developing robust charging infrastructure and ensuring the availability of raw material will be crucial. A phased and strategic approach supported by collaboration between organizations like your school, so collaboration between the military, between organizations like your school, the industry, and the government will be essential for successful implementation. So as we look to the future, we strongly believe that the integration of electric vehicle with advanced technologies like AI and autonomous system will further revolutionize military operation. By embracing electrification, the military can achieve greater sustainability, operational effectiveness, and readiness for future battlefield scenario. With that said, again, I want to thank you, the team, for the invite, and I'll be on standby for any question or comments you may have. Over.
Thank you, Major Frank, for the great presentation. We'll see if we have any questions in the room. Yes, Professor. Yeah.
Thank you, Major. Appreciate the presentation. Very insightful. I have a couple quick questions. One is, so where do you expect these vehicles to operate in the near future? I have a feeling that, like, based on the experience with EVs, I wouldn't rely fully on them in the battlefield. Maybe for support might make more sense to me, but obviously I'm not that experienced in this. And the other question they have is, so there's been some efforts from the Army, DARPA side to create autonomous vehicles for essentially off-road driving. I'm just wondering if you think that would help, since considering like some of the vehicles that you're using are small vehicles that might not have any direct application in the combat zone, but might be useful for other purposes.
Yeah, I think that's a great question. I don't know if I hear you very well because, I am not in the room, so you came a little bit broken. But I think for summarize your question is, how can we implement that simpler for the future? And then you make reference to the DARPA. So this is how I'm going to summarize, and hopefully I answer your question very well. At the end of the day, it's a teamwork, right? The military has a need. In order for us to meet that need, we have to work together. Organizations like the University of Illinois, industry, private sector, and partners, international partners, we need to work together from a science and technology perspective, first to validate the science, because it won't be impossible for us to meet our goal if the science does not exist. So step number one, we need to validate our science. And I agree with you, it's not an easy fix. right? The idea is great, but the science is a little bit challenging. I think that's step number one. Step number two, we need to validate the technology, and that comes with first having a proof of concept, and that means first having a proof of concept that you can test in a very safe environment, and then later deploy that in an operational environment, right, where you can truly validate the technologies. And then I think when you do all those things, then you can enter into production. When you saw in my brief, I have a glide path. The glide path should take us up to 2050, but you can see that as a phase approach, right? Because the military, in this case, the army, is knowledgeable of the fact that yes, you can have great ideas, but sometimes realities will kick in, and maybe some of realities can delay the process. But at the end of the day, we want to be there because we have a strategic imperative that we need to meet. We have an operational need that we need to meet. We have an environmental goal that we need to meet, and also we have a leadership, I will say, example, right, goal that we also need to carry. Now, when it comes to the DARPA piece, I want to really speak on behalf of DARPA because I'm not part of DARPA, but I know that across the services, Army, Navy, you name it, right, there is a push, right, to go toward a autonomy system because this is the future, right? I mean, the private sector the private sector has a couple of prototypes, right, that they deploy that people use now. So yes, and why not for the military down the road? Over. And I hope I answer your question.
We have one more question, Muhammad.
Thanks for the presentation. I was thinking, would you say that the usual military contractors are ready to take these blueprints or designs that you're coming up in research and create or mass produce these vehicles that you're trying to deploy? Like, how would you see their readiness in terms of production?
Okay, all right. So that take me back again to the first question, right? So when it comes to engineering, it's a process. Step number one, and I'm going to answer the question about the contractor, but I think they kind of go together. So when it comes to engineering, is a process. Step number one, you want to validate the science, and who validate the science? People like you validate the science, right? People write white paper to say yes, the science exists, right? And then organizations like us take those white paper, take those validation, and validate the technologies and say, yes, the technology that exists. And then we can go and recruit the contractor, in this case, the private sector, say, yes, we did validate the science, we did validate the technology in our lab, right? But now you can take what we did, take that to the next step. So it's a team effort. So to answer your question, to see if we have contractor ready to do that, I will say to a certain extent, yes, because it's a team effort. The challenge will be if the army was by himself trying to solve those problems, then I will say no. But it's a team effort. It's a team effort that includes academia, that include private sector, that include government entities, and together we can fix those problems. Now, the thing that I want to highlight, sir, it is, and that's just my point of view, right? We may not reach the 2050, letters that we wrote in the sand, right? We may not, right? I'm not saying we will. I'm not saying that we won't, but that's a possibility. But it does not stop us to at least start the process, because you got to start somewhere in order for you to arrive at the place where you want to be. So to summarize, sir, it is a team effort where academia, like organizations like the University of Illinois, have a role to play, like private sector have a role to play, like lab such as UCAS, ERDC, DevCom have a role to play. And if we play all those roles and we work together, there is no reason why we can't meet those goals. Over.
Thank you.
My pleasure.
Do we have more questions in the room?
Okay.
We actually have some questions on Zoom.
Okay.
The first one, what are the typical cost premiums for all electric and hybrid vehicles?
What's the question?
What are the typical cost premiums for all electric and hybrid vehicles?
I think this is a technical question. I don't know if I have that answer about the typical. I assume they're talking about the cost, the APAC, the acquisition, the acquisition procurement unit cost. What I can tell you is it's not cheap, right? Everything has a cost. It's not cheap. I don't have a specific dollar amount, but it's very expensive. If you have listened to my brief, one of the key challenges that we have was the upfront cost, right? It would take a lot of money in order for us to be there, but we can do it as a country and as a nation. Over.
Okay, we'll take one question also from the room. Anjali?
Okay.
I think, wasn't sure. Thank you, Major. My question is, so you presented different options, like the battery powered, and then you saw the solar, and then you talked about hydrogen. I was just curious if the Army has either a priority or if you foresee using different types of fuels or renewable energy, and what is the outlook in that?
Okay, all right. I think this is a great this is a great question, and this is really what I think, right? What's your background? What do you do?
I'm a pavement engineer.
Okay, all right, fantastic. Here we go. You have the answer. So we need people like you to investigate. You remember I said somebody has to do the science, somebody has to do the technology, and somebody has to do the demonstration, put that together, right? So academia, you got to validate the science for us because we can't do that by ourselves. It would take forever. So we need people like you in school to start thinking of those different venue of energy. I mean, listen, the world's all, there's so much we can do. There's different ways to create energy, right? But we need smart people like you to take the time to think. You work on your PhD, I assume, or something like that. I mean, start working on something to say, okay, all right, how can we innovate in that area? We know that we have to go to full electric down the road. But how do we do that? What is the smartest way to do that? How fast can we do that? So we need academia to do that piece, right? This is the science. And once you finish to write your white paper and did your dissertation and you found something great, then you send to our lab. We're going to pick up what you did. We're going to build a concept, right? Using your findings, right? And then we're going to create a prototype number one. We're going to test that in the lab to first verify everything that you send your white paper. Say, yeah, she's right. And then we're going to kind of move to what we call a much mature prototype and say, yes, it's working. We're going to push that in our operational environment. And then we're going to bring the private sector now and say, listen, private sector, the science exists, the technology exists. This is a TRL. TRL stands for technology readiness level. This is a TRL4. Take it. I want that to become a TRL8. A TRL8. That means mature enough that a soldier can use. This makes sense? So to come to your question, there are a lot of opportunities in that space, and we need people like you to help not only the Army, but to also help the nation to find the next cool things. Over.
Thank you so much.
Pleasure.
We also have one more question.
Yeah, so not so much of a question, but Major Nago, thank you so much for the presentation.
My pleasure.
I know him very well. We work together. I am also at Searle. I've also worked here at the University of Illinois. And I just want to take this opportunity in the spirit of that last response to let everyone know we have a CRADA, a cooperative research and development agreement. We had one with Searle, just the one lab there in Champaign, but last summer, CRADA was signed with ERDC, which is the 7 labs that make up the Engineer Research and Development Center. Not only that, but I just saw some statistics that Searle had far and away the most student interns this past summer session, not exclusively from the University of Illinois, but largely so. So, we like to think that we have a lot of smart people doing a lot of cutting edge work, and we do. But we know that we don't have, we haven't cornered the market on that. And so we want to leverage our relationship with the University of Illinois and all of academia and to, we do advance that. So yeah, we work to that extent. I mean, I've got a project with Railtech. I've been in contact with the people here at ICT. So we are definitely looking for those opportunities. Like I said, that CRADA is in place. So don't think that you're giving away your research to Searle, ERDC, the Army, etc. I mean, they have money, so we're looking to, leverage everything that the university is doing here to help support our mission as well. So I just want to interject that. Thank you. Yep.
Thank you.
Also an agreement between ICT and ERDC. Yep.
Thank you. We actually have more questions on Zoom. The next one is, did you indicate the armed force is trying to achieve 100% non-fossil fuel vehicle ground fleet?
So the goal, when you look at the Army climate strategy that was published 2022, The goal, at least for the Army, is to be able to have an all-electric vehicle by 2050. Over.
We actually have also one more question from Professor Kontu. She's
Yep.
asking, what are the lessons learned from electrification of unmanned aerial vehicles deployed in the field that can transfer to ground vehicles?
Oh, I think that's a very, I think that's a very good question. I think one of the biggest things that we're learning, no matter what the means is, no matter what the when I say the mean, I'm talking about in reference to a question. One of the key challenge that we have is the charging infrastructures, right? You're gonna need, because let me explain. A military, when we deploy and we fight and we go to war, we have to be mobile, right? You don't come and sit somewhere in a nice place, drinking some nice coffee and watching some nice TV. So most of the time when you deploy in a hostile environment where you have to fight for your countries, and sometimes your life is online. So you have to move. You have to move sometime, every 30 minutes, every hour, whatever the deal is. That's how you survive in the battlefield. So we need something mobile. The challenge that we have with everything that's electric, it is that charging infrastructure, right? You need to have that charging infrastructure. And unfortunately, where we stand in time and space with frequent technology, we don't have the right charging infrastructure, right, for a mobile operation environment. And I think that's one of the biggest challenges that we have. And that's one of the biggest lessons learned when it's come to taking what has been deployed in the field. Is how do you do that? How do you deploy a mobile charging infrastructure which is able to move with the fighters, right, to go and meet that operation mission. So to summarize and to keep it very simple, I think being able to have a mobile charging infrastructure is one of the key lessons learned so far that we have learned. Over.
Thank you.
Pleasure.
If we don't have any more questions, I guess we can end the seminar. Everyone join me in welcoming Major Nago and thanking Major Nago for the presentation.
Yes, I just want to add two key things, and I appreciate the invite. I think it was a fantastic pleasure to speak to the team here. But you have to remember, this is a team effort, right? It's a team effort. We need your help. We need smart people like you to validate the science. We need the private sector to do the piece, and we need partnership. That's all I will have to say. And I think as long as we all work together, there's no reason I won't be able to meet that deadline. Over. Thank you
So much.